What's up, everybody, and welcome back to another video from the Scalar Learning channel on SAT Math. And this one is one that I'm so excited about. I've been working on it for a long time, and it is me solving the hardest SAT math problems that I could find from practice tests from the College Board. Now, again, these are all pulled from official practice tests from the College Board, and you'll see on the screen for every question that I'm solving where it can be found in the practice tests. So this question is particularly difficult because it's sort of this fraction in a fraction and you need to simplify. And the first thing I want to point out is this inequality of x is greater than 3. Usually don't really have to worry about those because they're generally just removing the possibility that this denominator could be 0 and the whole thing is undefined. So the fact that it's greater than 3, it's great, you need it, but you don't really have to pay attention to it. Now, what they've obviously done is simply simplified this expression. Your first instinct might be to just flip the whole thing and make it x plus 2 plus x plus 3, which will give you c. That is actually incorrect, and I'm going to show you why. The first thing you have to do is consolidate these guys. We can't just flip them. They need to be in one singular fraction, then you can flip. So how do we do that? We need common denominators. So I'm going to multiply like so. We're going to have x plus 2, x plus 3, and I'm going to multiply this guy by x plus 3, but we also must multiply the numerator. And I got to multiply this guy by x plus 2 and also must multiply the numerator. Now you can see they have common denominators, x plus 2 times x plus 3. Now we can just simply add the numerators. So x plus x becomes 2x, 3 plus 2 becomes 5. Over, and let's FOIL this only because they've clearly done that in these answers. So this becomes x squared plus 5x plus 6, and this is still over 1. Now what we can do is now, since it's 1 over this, now we just flip it, take the reciprocal, and it becomes x squared plus 5x plus 6 over 2x plus 5, and B is the answer. Boom, done. Next, we got a question that hits the exponent rules pretty hard, and what makes it quite difficult is it's not just exponents, it's also a hybrid system of equations. So here's what we're going to do. First, I'm going to look at this expression, and whenever I'm thinking about exponents and simplifying with exponents, I need to have the same base. I want to go there first. So I see an 8 and I see a 2, and that's pretty cool because 8 can be rewritten as 2 to the 3rd power, all right? But that value is still to the x power over 2 to the y power. Now we use our exponent rules and multiply in. Now I have 2 to the 3x over 2 to the y. Now because I have the same bases, I can combine these and make it 2 to the 3x minus y. So this is a pure simplification process. I'm not even necessarily, I know I'm getting numerical answers, but I'm not even necessarily looking at them yet. I'm just simplifying to the best of my ability. Now we're going to look up to this equation and realize that we found something really amazing because 3x minus y, we already know what it is. It's 12. 2 to the 12th is the answer. Boom, done. This is a pretty difficult trigonometry problem for 2 reasons. Number 1, they don't even draw a triangle for you to look at. Number 2, it relies on a particular rule that says this: sine of x equals cosine of 90 minus x, meaning sine of an angle equals cosine of the complement of that angle. Now, if you know this rule, this is pretty straightforward. Oh, by the way, it's also free response, so there's no multiple choice to guide you. But if you know this rule, boom, you're straight up done. If you don't know the rule, it's a lot trickier. And if you don't know the rule, this is what I would do. So I would draw out a triangle. There's your right angle. It's not the best triangle. And let's say here's angle x. So if they're saying sine of x is 4/5, what I would do is say the opposite side is 4. Just designate the opposite side as 4. It doesn't matter. It could be 40 and this could be 50, but let's just keep it simple. 4 and the hypotenuse would be 5. Now, then you'd figure out like what is 90 minus x? Well, obviously it's the complement, which means 90 minus x is this angle up here. And then just apply your general cosine rules. Cosine is adjacent over hypotenuse, which of course gives you 4/5. This one is pretty tricky just because of the expression that they want you to provide the answer in, and it can be a little confusing. So let's go ahead and read it carefully together. And by the way, a big tip is I'm going to be underlining all the numbers and the variables as I read. So Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was P dollars. So after the 20% discount, she paid P dollars. And then that includes an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? So again, P is what she finally paid. I like to create my expression first and then relate it back. So if we have our original price set to X, which they didn't give us that variable, so I'm going to set my original price to X, then what they're doing is they're taking a 20% discount. Well, if I'm taking a 20% discount, sure, I could take 20% of this and subtract it again, but a much easier way is to just take 80% of this guy. So now I'm paying 80% of the original price, but then I have to also add on an 8% sales tax. By the way, I forgot to underline that. An 8% sales tax, which means I'm taking this quantity and I'm adding on 8%. So again, I could take 8% and add it back to this, but the easier way is if I'm adding 8%, see how here I took 20% away from 1, or 100 you could say. Here I'm going to add 8% on to 1 or 100 and make it 1.08. That will increase something by 8%. And then this will equal the value P. Now they said, which of the following represents the original price? And by the way, I designated the original price as X, so all we got to do now is isolate. So to isolate, I'm going to divide by 1.08 times 0.8. 1.08 times 0.8. Boom, boom. And this is the original price equals P over that. And we don't even have to evaluate it. If you do want to take a quick glance at the answers, you'll see that, hey, look, they're all in this format. It's really nice and straightforward. D is your answer. Done. Now we come to a good old-fashioned circle equation problem, and what makes these problems pretty difficult is just the fact that you have to memorize this lengthy equation of a circle, but you gotta learn it. You gotta put in the time and make sure you have it down. Here's the equation of a circle. It is x minus h squared plus y minus k squared equals the radius squared. So this is really helpful once you know this, and then we just have to put it into the format with these numbers. And by the way, H and K are the center of the circle. So we've got a center of 0, 4. I can plug that right in. That's pretty nice. So it's going to be x minus 0, which is just x squared, plus y minus 4. We got to make sure it's not plus. It's always minus that if it's positive, equals whatever the radius is squared. But I don't know what the radius is. How do we calculate the radius? Well, here's the nice part is I have a center and I have an endpoint at the end of a radius. So to calculate the length of the radius, simply use the distance formula. So here we go. The distance formula is as follows. We take the difference of the x values, so 0 minus 4/3 squared, plus the difference of the y values, 4 minus 5 squared. This equals the square root of, that's just negative 4/3 squared, which is 16/9. This is negative 1 squared, which is just 1. And then 16/9 plus 1 is, we could write this as 9/9, by the way. And 9 plus 16 is 25, so this becomes the square root of 25/9, which reduces to, you just take the square root individually, so it's square root of 25, which is 5, square root of 9, which is 3, and it's 5/3. Since the radius is 5/3, I just plug it in here, boom, and square it, and we have our equation for the circle. Now, in these final answers, they've, of course, squared this back to 25/9, so we can see that we can eliminate those two guys. Here is almost correct, except they have plus instead of minus, so B is out, and A is the winner. In this one, the question says, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation? So before we answer a question like this, we have to understand, what are they asking? What do they mean that the vertex is identified as constants? When they say something like this, they mean this has to be in vertex form, not in intercept form as A and B are, but in vertex form. By the way, C is not even, C is like, it may look kind of like vertex form, but it's not. It's actually D. And so if you know what vertex form looks like in this problem, D is the only possible option. But what's so confusing about it is, and this is also a question 30 in a calculator section, so it's usually always going to be one of the hardest questions. What's so confusing about it is what exactly are they asking? Now, if you look at the vertex, you can see, even if you don't exactly remember what vertex form is, you can see that the vertex looks to be like 1, -16. And I see a 1, and I see a -16. So that's further verification that we definitely know we're right, and we're done. So this is a two-part question, and really it's 38. That's the more difficult section, but I wanted to do both parts so we can see the entire process and development of the problem as we go through it. So Jessica opened a bank account that earns 2% interest compounded annually. That means just, the end value in compound interest is just 1. Her initial deposit was $100, and she uses the expression 100x to the t to find the value of the account after t years. What is the value of x in the expression? Now, when it's 2% and it's increasing by 2%, the way that we represent this, if we're talking about compound interest, by the way, here's the original setup. And because n is 1, I'm going to keep it real simple. This is the normal setup where r is the rate. Well, r would be 2, but not 2 as a whole number, 2 represented in decimal format because it's 2%, and that would be 0.02. And of course, 100, again, represents that initial amount, the principal. So it would be 100 times 1 plus 0.02 to the t power. And since x is sort of this entire piece right here, x is simply 1.02. Now we come to 38, and notice that 38 is building on 37. And if you get 37 wrong, you're kind of hosed. But hopefully you'll get 37, and then you can get 38. So it says, Jessica's friend Tayshawn found an account that earns 2.5% interest. Again, I'm underlining the numbers. Tayshawn made an initial deposit of 100, just like Jessica, into this account. At the same time, Jessica made a deposit of 100 into her account. After 10 years, how much more money 10 years, how much more money will Tayshawn's initial deposit have earned than Jessica's initial deposit? Okay, so the way we do this is, oh, by the way, let's read these other details. Round your answer to the nearest cent and ignore the $sign when grading your response. So we need to get expressions for both of these. So first of all, we already know that Jessica's is 100 times 1.02 to the 10th power. Now, Tayshawn, he says 2.5%, so it's 100 times 1.025, and also to the 10th power. So what we're doing in this case is we're just basically looking at this value minus this value, round to the nearest cent, and we're good to go. And this is a calculator problem. You could theoretically do this without a calculator. It would just take you so long. It would be so painful. So we're going to jump to a calculator right now. Okay, so what I'm going to do in my calculator is I'm just going to put in essentially the expressions and subtract them so I don't have to calculate these, make sure I don't round too much and all that stuff and write down a bunch of numbers. This is just going to be to save time, but you got to be super careful that you don't make any mistakes. So 100, so I'm going to triple check my numbers here, times, this is Tayshawn's value, because that's the larger value, to the 10th power. And it's that minus Jessica's amount, which is 100 times 1.02 to the 10th power. Now again, it says round your answer to the nearest cent very specifically, so we can't just write 610, it would be incorrect. The correct answer rounding up is 6.11, boom, done. Next, we have this very interesting quadratic question, and it almost looks like a synthetic division or a long division problem, but I'm going to show you how I would break it down. Again, it gives you this condition, x does not equal 2 over a, but that's simply to remove the possibility that this denominator could go to 0 and it could be undefined. So when it says this equation is true for all values, it basically means these two sides are equal to the same. So then we're trying to figure out what is the value of a that makes it that way. All right, here's what I'm going to do right off the bat. I see these looking pretty equivalent, but on the left side, everything is over ax minus 2. On the right side, that's not the case because this guy is just floating over 1. So what I'm going to do is I'm going to take negative 8x minus 3, and I'm going to multiply it times ax minus 2 over ax minus 2 minus 53 over ax minus 2. Guess what? Now we can consolidate everything because now we have the same denominator. But first, before I do that, I'm going to FOIL this guy like so. and I get negative 8ax squared plus 16x. Negative 3 times ax is minus 3ax plus 6 minus 53 over ax minus 2. Now I'm going to simplify by merging those guys. And these guys can't really be combined because of the a, but it's still pretty good. So we got negative 8ax squared plus 16x minus 3ax minus 47. So this is looking pretty good now, because if I look at the left side, there's a negative 47, there's a negative 47. Okay, but the nice part is I don't even though this looks like a difficult expression to kind of relate to 25x, I don't even need to worry about that, because this must be linked to this, because they're the only two terms that have x squared. As a result, in order for this to equal 24, a has to be negative 3. Now we can further verify that by plugging in negative 3 here. Negative 3 times negative 3 is 9. 9 plus 16 is 25, which matches with that, and we're done. This is a very, very interesting but sneaky problem using a formula that you've all seen, I'm sure, 100 times, which is the Celsius to Fahrenheit conversion, and vice versa. You can use it either way. So it says the equation above shows how a temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius. Based on the equation, which of the following must be true? Okay, so we've got to figure out which of these has to be true. And then is it 1, 2, 3, or 1 and 2, etc. All right. A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 Celsius. So the first way that you could do this is you could look at this and be like, all right, I can calculate the slope, I can figure out what makes sense, etc., because it is a linear equation. But I got a different way that I like to do these, and that's involving a table. And I think tables are really, really great for problems like these. So I'm going to put a Celsius column and a Fahrenheit column. And so the first question asks, if I do a 1 degree increase of Fahrenheit, does the Celsius go up by 5/9? All right, well, let's try it. I'm going to choose two really easy values of Fahrenheit. I'm going to choose 32, and then I'm going to choose it going to 33. That's a 1 degree increase in Fahrenheit. Let's see if Celsius goes up by 5/9. Well, if I plug in 32, I chose that intentionally because 32 minus 32 is 0. That's a starting temperature of 0 degrees. If I plug in 33, 33 minus 32 is 1 times 5/9 is 5/9. It looks like it has indeed gone up by 5/9. That is true. So immediately I'm going to look at this. B and C are out. So it's either down to A or D. Guess what? Do I really need to look at 3? No. Now all I have to do is figure out is 2 true or false. All right, let's see. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 Fahrenheit. So let's kind of do something similar here. Let's go with 0 to 1. And these numbers aren't going to be the prettiest, but it's still very doable. So when Celsius is 0, I already know that Fahrenheit is 32. What about when Celsius is 1? Let's plug and chug. So I got 1 equals 5/9 times Fahrenheit minus 32. Let's isolate, multiply both sides by 9/5. That cancels these. And then 9/5 times 1 is 9/5 equals Fahrenheit minus 32. I'm going to add 32 to both sides. And again, they gave me that decimal. Well, why don't we turn 9/5 into a decimal? Guess what? 9/5 is actually 1.8. So this becomes 32 plus 1.8, which is 33.8. But you guys kind of probably already see that this is indeed true, because when this goes up by 1, Celsius goes up by 1, Fahrenheit goes up by 1.8. So 2 is also true, which means A is out and D is the winner. This problem is an extremely difficult trigonometry problem, partially because they didn't draw anything out. And that abstract element of this problem makes it that much harder. So the first thing you got to do is draw out these triangles. So first we have triangle ABC. I'm going to draw that. We also have DEF, which is similar, and they both appear to be right triangles. So let's set that up. So notice how they said DEF is similar to that, where D, E, and F correspond to A, B, and C. So notice how I have D in the same spot as A, B is the same spot as E, and C in the same spot as F. B and E are, of course, the right angles, and now we can begin. So BC, they said, is 16, AC is 20, and we don't know this value. Of course, we can calculate it from Pythagorean's theorem. Then it says each side of triangle DEF is 1/3 the length of the corresponding triangle ABC. I'm going to pause on that information. I'm not going to necessarily designate anything yet, but first I want to fill in AB. So if you may have caught this, that's great. If you don't, you can use Pythagorean's theorem. But if you catch this, this is a 3, 4, 5 right triangle. The College Board loves to use 3, 4, 5s, and it's a multiple of that, but it's still a 3, 4, 5, which means this side is 12. You can verify that with Pythagorean's theorem, that 12 squared plus 16 squared is indeed 20 squared. Now we have this full triangle. So now it says, what is the value of sine of f? And by the way, C and F are equal. The easy way to do a problem like this is to recognize that sine of an angle is sine of an angle. It doesn't matter how big or small the triangle is because it's all about ratios. So guess what? I don't even need to calculate sine of f and put in the values and all that because it's the same as sine of c. I already have my values. So it's simply opposite 12 over hypotenuse, which is 20. And then this reduces by dividing top and bottom by 4, and we get 3/5 as the most simplified answer, and we're done. Now, if you did take the bait and actually fill in all these values, it would be 20/3, 16/3, and 12/3, which is 4. And then now, if you want to take sine of f, you'll still get the same answer. It'll be 4 over the hypotenuse, which is 20/3, which is the same as 4 times 3 over 20, which again gives you 12 over 20. That's the same deal. I find this problem pretty tricky because it's a combination of a system of quadratics plus function notation. So if you miss one of these elements, you're not going to be able to solve it. If you put it together, it's not so bad. So this says graphs of the functions f and g are shown in the xy plane. For which of the following values of x does f of x plus g of x equal 0? So first of all, what is that saying? That's saying when is the y value of this function, that's what it means by f of x, plus the y value of this g of x function equals 0. Okay, so let's look at some of these options. So at x equals -3, that's right here, both functions intersect. So you might be tempted to say that that's the answer, but both functions have a value of -1 right there. Well, -1 plus -1 is -2. That's out. So what about at -2? Well, the g of x function has a value of +2. The f of x function has a value of -2. What's 2 plus -2? It is indeed 0. And that's how you do it. We're looking for opposite y values so that when they add together, they cancel each other out and equal 0. Boom, done. So this is a pretty difficult problem because it's a hybrid volume question, which involves both a cylinder and a couple cones. But the good news is that these formulas actually are in the front of each math section. So you don't have to have them memorized, which is amazing because memorizing these could be pretty tough. I happen to have them memorized because, well, math is everything I do. So the volume of a cylinder equals pi r squared times height, which is really just the area of a circle times its height. So that makes sense. The volume of a cone is the same as that, but it's just with a 1/3 in the front. 1/3 pi r squared h. So we can see that they give us the radius, which is amazing. So first let's plug and chug for the volume of the cylinder. So it's pi times 5 squared, which is 25, times the height, which is this whole section, which is 10. And there we have an expression for that. Now we need an expression for the cones, but there's 2 of them. So again, it's 1/3 pi, same radius squared, which is 5 squared, which is 25. And what's the height? It's 5. But again, this is just one of them. We need the ones on the top and bottom, so I multiply it by 2. And guess what? This is a calculator problem. Obviously, with all these decimals, you're not going to be able to do this mentally or on paper with any great deal of time efficiency, so let's go for it. Pi times 25 times 10 plus, and again, I'm going to be overcautious with the parentheses, 2 times 1/3 times pi times 25 times 5 equals 1047.19, or as they did, rounded up to 0.2. Your answer is D, and we are done. This one is a straight up exponential problem, but what makes it difficult is the time period. So I'm going to read through it and I'll explain how to tackle it. In planning and maintenance for a city's infrastructure, civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. So again, how is this going to show up in an exponential? It's going to be 1 minus that 0.1, aka 0.9. So I should be seeing a 0.9 in the correct answer, which means A and B are out. This would be a 90% drop. And again, every 20 years. If it just said every year, this would be really simple. This would be 0.9 to the t power and we'd be done. But it says every 20 years. So we're going to think about how to break that down in a second. If the present population of the city is 50,000, which means that the starting value, the initial value is 50,000, which it is correctly placed in all of these, so that doesn't help us limit the choices. Which of the following expressions represents the engineer's estimate of the population of the city t years from now? So we got these two, and they both have 20 in the mix. So the question is, which one is the correct representation? Is it this guy or this guy? And you may have a sense for it, but if you don't, here's the key. It says it's going to decrease by 10% every 20 years. That means in 20 years, this population should drop by 20%, which means that in 20 years, this population should decrease by 10%, which you know mentally 10% of 50,000 is 5,000. What does that tell you? That means that if you plug in 20 to the correct solution, you should get 45,000 for the result of the population. Well, if I plugged in 20 up here, it'd be 0.9 to the 400th power, which is huge. It's going to be crazy. It's going to be nothing close to 45,000. It's going to be really small. However, if you plug in 20 here, you're going to get 20 over 20, which is 1. That's 0.9 to the first power, which is just 0.9, times 50,000. You can use your calculator if you want to verify this, but this is the 45,000 that we were searching for, which means C is out and D is the winner. This is one of the trickiest problems, in my opinion, that for me, it's caused me great difficulty every time I've had to look at it and approach it. So we're going to do it together, and I'm going to show you how I'll break something like this down. So it says Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5. Assuming gasoline costs $4 per gallon, which equation can Alan use to determine how many fewer miles M he should drive each week? So the first thing I'm going to do is I'm going to express this cost as a rate. So I'm spending $4 per, which is kind of like a synonym for divided by. So it's $4 for every 25 miles. So to calculate how much money I'm actually spending, for example, is I'd multiply this by the number of miles I'm driving. So if it says 100 miles each week, if I multiply this by 100, I could calculate how much money he's spending, which would be 400 over 25 or 16 bucks. So he's trying to get down to only spend $11. But this isn't even asking for those specific values. That's the beauty of this. We're just trying to find a simple equation that can tell us the amount of miles he needs to reduce his driving by each week. So again, we're going to take that rate and we're like, all right, well, I know I'm spending $4 for every 25 gallons. So how many miles, again, because we take the miles and multiply it by this to get how much we're spending, how many miles is equivalent to $5? If you express it in that way, if you're just breaking it down as a monetary rate per mile and simply set that equal to 5, which is the target that you want to drop the price by, it's actually not so bad. D is the answer. Boom, done. At first glance, this problem looks crazy difficult. How are we supposed to figure out what this value A is? But it does say the expression above this guy is equivalent, meaning equal to this. So we're going to start off by representing what that is saying, which means these two guys are literally equal to each other. So x plus 2 squared minus 2 over x plus 2 equals a over x plus 2 squared. So what I'm thinking is if I can consolidate these two guys into x plus 2 squared as a singular denominator, I can quickly figure out what a is. So how would I do that? Well, x plus 2 squared on this side, well, I have to also multiply this by x plus 2 to get x plus 2 squared. If I do that, I must multiply the numerator by x plus 2 as well. Now as I distribute, I've got 2x plus 6 minus, in parentheses, 2x plus 4. And it's important to keep it in parentheses to remember to distribute that minus. And this is now all over x plus 2 squared. It's looking pretty good. Distribute them negative. Distribute the negative. Now I have 2x plus 6 minus 2x minus 4. Again, because of the distribution over x plus 2 squared. These guys cancel because they're opposite. 6 minus 4 becomes 2. So finally, we have 2 over x plus 2 squared is apparently equivalent to a over x plus 2 squared, which means lo and behold, a equals 2, and we're done. Next, we have this guy, which is quite confusing when you first look at the drawing and the diagram, but really it's just something turning, spinning, and this is some sort of a graph. It says the figure on the left shows a wheel with a mark on its rim. And there is the mark right there. The wheel is rolling on the ground at a constant rate along a level straight path from a starting point to an ending point. The graph y equals dt, which is this guy, on the right could represent which of the following as a function of time from when the wheel began to roll. So immediately as I'm looking at this mark, I'm imagining it coming down to here and going back up. And when I look at this function, it kind of looks like something is going down and then it's coming back up. So my immediate instinct is that this graph is a representation of the height of this little dot thing. The speed at which the wheel is rolling, I don't believe so, because it said that it's rolling at a constant rate. So if it was representing that, this should be a constant line like that, but it's going up and down, so that's out. The distance of the wheel from its starting point, I don't see how it would be oscillating unless it's going back and forth, right? But it looks like it's just going in that direction. That's out. The distance of the mark on the rim from the center of the wheel. This almost looks good. The only problem is, wait a minute, as it goes around, it's the same distance from the center always. So that would again be a constant. Last but not least, the distance of the mark on the rim from the ground, and that's what we logically deduced anyway, so D is the answer, and that's it. This one says the surface area of a cube is 6 times a over 4 squared, where a is a positive constant. Which of the following gives the perimeter of one face of the cube? Man, so this is super difficult because there's no diagram. We've got an a in the mix. So the first thing we're going to do is we're going to draw out a cube. So first of all, since they give me the surface area, again, surface area is each and every face added up. How many faces are there on a cube? There are 6. That means that if this is the surface area, well, guess what? The area of just one face is a over 4 squared. And that's really helpful because if I know that, now I can start to get the side lengths of this cube, and that is what we need if we're going to get the perimeter. So if this is the area, first of all, these sides are all equal, but if this is the area, the question is what times what gives me a over 4 squared? Well, it's going to be a over 4, right? Because a over 4 times a over 4 is literally a over 4 squared, or a squared over 16. Great. Now I need the perimeter of one face, which is just simply these 4 sides. Well, they're all a over 4, so the perimeter would be 4 times a over 4, which is just a. In this case is option B. Boom, done. This is a high difficulty linear equation problem because it's a hybrid of graphing, linear equations, and function notation. It says the graph of the linear function f is shown on the xy plane. The slope of the graph of the linear function g is 4 times the slope of this. Well, first of all, what is this slope? It looks like it's going up by 1 and across by 2. So the slope of f is 1/2. The slope of g is 4 times that. Well, what's 4 times 1/2? It's, of course, 2. So the slope of g is 2. I'm going to write it like that. If the graph of g passed through the point 0, -4, and by the way, that's a y-intercept because the x value is 0, what is the value of g of 9? So first let's get our equation for g, which is, it's linear, so it's 2x, because that's my slope, minus 4, because that's the y-intercept, -4. Great. And then what is g of 9? Now I just plug 9 into this function, and I get 2 times 9 minus 4, which is 18 minus 4, which of course is 14. C is the winner, and we're done. Now we got 36, which is a very high-level geometry problem, and it's a circle triangle hybrid, as many circle problems are. So let's take a look. Point P is the center of the circle in the figure above. What is the value of x? So they don't give you a lot of information in the setup. We're trying to find this angle. There's a few ways to approach this problem, and I'm going to probably try and take the path of least resistance. And what that path is that if I have an angle that's on the circle like this, and I have another angle that's a central angle, and they both intercept the same arc, I know that there's a particular relationship between these two, which is that this angle here is half of x. Next, what I'm going to do is I'm going to draw in another radius, and this is often an amazing way to approach a lot of these. The great thing about radii is that we always know that they're all equal. So I know that this is equal to this. And if that's the case, these opposite angles are equal, which means this little angle in here is 20 degrees. I can say the same thing for this because this is also a radii. So those two sides are equal to isosceles triangle, which means the opposite angles are equal. This angle in here is 20 as well, which means this entire angle of BAC is 40. And I have designated that entire angle as 1/2 x. So that means 1/2 x equals 40, which means this x value here can be solved by isolating, multiplying both sides by 2. And x, of course, equals 80. Boom, done. All right, this is a very interesting quadratic parabola problem. It says the vertex of the parabola in the xy plane above is 0c. Which of the following is true about the parabola with the equation of this? Okay. And by the way, we're kind of assuming that the a's are the same. Now, what can we deduce about these values? I know that c is positive. I also know that a is positive. And why do I know that? Because a dictates whether or not this thing goes up or down. If it's going up, a has to be positive. Now we say, which of the following is true about this parabola? And again, what makes it so difficult is this is so abstract. I don't have concrete numbers, so we really have to break out things like this and say c is positive, a is positive, etc. So now in this case, that a term, because there's a negative there and it was positive, it's negative. So this thing is going down. I also know that it still is going to have a positive y-intercept because that's the c, and we don't know anything about b. All right. The last thing to note is that this is in vertex form, so I do want to say that the vertex is b because it's the opposite of this, comma, c. Great. So the vertex is BC and the graph opens upwards. Almost, except we said it opens downward, you're out. The vertex is BC and the graph opens downwards. This is correct. The vertex is negative BC. Now here's where they're tricking you. Remember, in vertex form, which you got to be familiar with, it's x minus the x coordinate of the vertex, which means it's always the opposite. So if it's minus b, it's going to be a positive b for the vertex. So you're out, and this has the same error. Which of the following is equivalent to this guy? So what is this problem? This is a long division, a polynomial division problem, and that's the best way to approach this. So I'm going to show you how to set it up. We got 4x squared plus 6x divided by 4x plus 2. So when we do polynomial division, all we do is we look at the leading term. So first I see how many times does 4x go into 4x squared? Well, it goes in x times because x times 4x is 4x squared. But then we must also multiply it to that term, and that's 2x. Now, just like in regular long division, we're going to subtract. But what I like to do is I say negate, negate. Those cancel out. 6x plus negative 2x is 4x. And now we repeat. 4x plus 2 goes into 4x how many times? It goes in 1 time. So 1 times 4x plus 2 is simply 4x plus 2. Again, we subtract, negate, negate. Those cancel, and we're left with a remainder of negative 2. And now we know to stop because this is a pure constant, and this has a variable in it. So we don't go any further. So the final answer is x plus 1 with a remainder of negative 2. So we write the negative 2 like that. And the negative 2 just goes on top of that divisor, which was 4x plus 2. All they did in the answer was instead of writing a plus negative, they made it a subtraction, but D is the winner, and we're done. How many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution? So mixture problems aren't that bad, but if you forget how to do them, you're pretty much stuck. And this is also a free response question, which makes it that much harder. So the question is, how much of a 25% solution, again, that's the how much, must be added to 3 liters of a 10% solution to obtain a 15% solution. But here's the kicker. We don't just want to say 0.15. We want to say 15% of whatever the total volume is, and that is x plus 3, because we got x liters of this and 3 liters of this. So we want 15% of x plus 3. Now we got a beautiful equation, but it can get even better. Notice how I have decimals. Well, I don't really want to deal with decimals. So I'm going to multiply everything times 100. And I can do that. It becomes 25x plus 3 times, again, I don't multiply both of these by 100, just one of them, and then we're good to go. So 100 times 0.1 is 10 equals 15 times x plus 3. Then I've got 25x plus 30 equals 15x plus 45. Then I'm going to subtract 30 from both sides. And then I've got 25x equals 15x plus 15. Subtract 15x from both sides. And I got 10x equals 15. Divide both sides by 10, and I get x equals 1.5, and we're done. This question is no joke with the gears and the diagram and all this stuff, and then this ratio. So it's super, super intimidating, but we're just going to break it down step by step. A gear ratio, R to S, is the ratio of the number of teeth of two connected gears, okay? The ratio of the number of revolutions per minute of two gear wheels is the inverse, S to R. So this is R to S is the number of teeth of two connected gears. The ratio of the number of revolutions per minute is S to R. In the diagram, gear A is turned by a motor. The turning of gear A causes gears B and C to turn as well. If gear A is rotated by the motor at a rate of 100 RPM, what is the number of revolutions per minute for gear C? So we're going to just plug and play now. So first of all, what is the gear ratio of A to C? Well, it looks like it is 20 teeth to 10 teeth. Great. Which means that the ratios of the revolutions per minute of each one is the inverse of that, which is simply going to be 10 to 20. Okay, very interesting. Well, now if I know that the revolutions per minute of gear A is 100, then C is simply going to be 200, and that's it. Now I want to think about this logically. Does that make sense? Yeah, if it's a smaller gear with less gears, it's probably going to be spinning faster, right? If it's going at the same rate, it's going to have more revolutions per minute. So 200 makes sense. It can't be 110 or 110. I guess it could be because it's more, but it just doesn't seem like a large enough jump. And 1000 just doesn't seem logical because it would be so much faster. A motor powers a model car so that after starting from rest, the car travels S inches in T seconds, where S equals 16t times square root of t. Which of the following gives the average speed of the car in inches per second over the first t seconds after it starts? Okay, so a problem like this is super intimidating in my opinion when you first look at it because I don't really know what's going on. But if you remember that this is simply distance equals rate times time, this becomes a lot easier, where distance is S, rate we don't know, and t is just t. That's it. So how can we represent this? Well, wait a minute. What if I move things around? Because that t over there is the time. And then what's left over is that 16 root t. So if these all link up, the s is my distance, the time is my time, and the rate is what's left over, which is 16 root t. This isn't so bad. B is the answer, and we're done. A school district is forming a committee to discuss plans for the construction of a new high school. Of those invited to join the committee, 15% are parents. So I'm immediately bringing this information out. 45% are teachers. And 25% are administrators. And the remaining 6 individuals are students. Now here they don't give us a percentage, but they tell us it's 6. How many more teachers were invited to join the committee than district administrators? So here's what we're going to do is first, we have to look at these different categories. We have percentages, and that we have amount of students. Well, the nice thing is if this comprises everything, then whatever the percentages here will add with these to make 100. So the 15 plus 45 is 60, plus 25 is 85. So this has to be 15%. Now there's a couple ways that we can get to our answer now. We can set up proportions, or you can kind of realize that if 15% is 6, if I divide both of these by 3, 2 is the same as 5%. So now I can do some really quick math. If that's the case, then this is 10 admins. This is 9 times 5 is 45, so 9 times 2 is 18 teachers. And again, 15 is the same as students, so there's 6 parents. So it says, how many more teachers were invited than the district administrators? So it's 18 minus 10, which is 8, and we're done. All right, this is a pretty darn difficult and intimidating looking rational exponents problem. So we're going to break it down step by step. We also have to use exponent rules to simplify it. So it says the expression here where x is greater than 1, y is greater than 1. Again, don't really have to worry about these because these are just so we're out of the possibility that we're going to get some weird answer. So just kind of, yeah, great, but we don't really pay attention to that. Is equivalent to which of the following? So what I'm doing is I'm looking at these answer choices and I'm realizing, what have they done? Well, they've gotten rid of these negative exponents for sure, and they've also gotten rid of these fraction exponents and turned them into radicals. The first thing I'll do then is I'll move that -2 to the denominator. So now it becomes y to the 1/2 over x to the +2, and that's all we do. When we move the negative either up or down, it just becomes the opposite, becomes positive, opposite sign, and then times x to the 1/3, and then that y to the -1 jumps up to just be y, or y to the 1. Now we're going to use our exponent rules. When we're multiplying, we're adding. So 1/2 plus 1 is 3/2 on top, and on the bottom 2 plus 1/3, that becomes 2 1/3, or 7/3. Now we're going to rewrite these guys in radical format. So this is the square root of y cubed over, right, because the denominator is the root and the numerator is the power, over x to the 7th cube root. Last but not least, we're going to simplify. So I can simplify square root of y cubed because it's really y squared times y, and that becomes the square root of y squared is y, so that comes out of the square root prison, and the y is stuck inside. For this one, it's the cubic root of x to the 7th. Well, this is the same as the cubic root of x to the 3rd times x to the 3rd times x. Well, these are both perfect cubes, so they both come out as x and x. So it's like x times x, which is x squared. And then we've got the one lone x trapped inside, like so. And if we look at the answer choices, that most closely links up to D, except the parentheses, but we're done. This is a two-part question, but I'm only focusing on 20 because you don't really need 19 to answer 20, and 20 is the really difficult one. So it says we've got Mosteler's formula and we've got Current's formula, and those are always great to have in a problem. We can really use those equations to our benefit. So it says the formulas above are used in medicine to estimate the body surface area A in square meters of infants and children whose weight ranges between 3 and 30 kilograms and whose height is measured in centimeters. If Mosteler's and Current's formula gives the same estimate for A, which of the following expressions is equivalent to this? So first of all, if they give the same estimate for A, that's telling me that all I'm going to do is set these guys equal to each other. Next, it says, which is equivalent to this? Well, if that's the case, I just want to isolate this guy. So guess what? I'm going to multiply both sides by 60. The square root of HW equals 60 times 4 plus W over 30. Now I can use a little simplification, cancel, cancel. This becomes 2 over 1, or just simply 2. So then 2 times this is just simply 2 times 4 plus W. And normally I would simplify and make it 8 plus 2W, but the answer is given in this format. So we stop there and we're done. The manager of an online news service received the report above on the number of subscriptions sold by the service. The manager estimated that the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. So whatever percent increase here, this would be double whatever percent increase is here. How many subscriptions did the manager expect will be sold in 2014? So yes, this is a straight up percent problem, but I do find it difficult the way that it's given. It's also got this information, and it's also like reverse. It's saying this, the previous one is double. So really what it's saying is this is half of that. Thankfully, this is a calculator problem, so that helps a lot. So how do I calculate the percentage increase here first? Well, we take the fact that it went up by 280, right? 280. And then to calculate that as a percentage, we throw it over the original. To figure out what this is as a percentage, I can simply say 280 divided by 5,600. We could use a percent proportion, but also if I know that I just move the decimal over twice, I've got my answer. So this is a 5% increase. Now, if that's the case, that means this would be half of that, which would be a 2.5% increase. So if we're trying to figure out how much will be sold in 2014, we tack on a 2.5% increase to 5,880. So 1.025, that includes the increase, times 5,880 gives me 6,027. So the winner is B, and we're done. In the figure above, tangent of B equals 3/4. If BC equals 15, boom, I'm going to put that in the diagram. BC equals 15. and DA, which is this little chunk, is 4, what is the length of DE? So this is my unknown. Now, when they say tangent of B is 3/4, that applies to both the little triangle and the big triangle, which is pretty cool because these two triangles are obviously similar. They both have that angle that they share and they both have right angles, so angle-angle similarity. Now, if that's the case, tangent of B is 3/4. That means opposite over adjacent is 3/4, which means that if I were now to call this unknown side 3x, I could call BD 4x. And again, I'm just doing that so I don't have to deal with fractions. Now again, as I've mentioned many times, the College Board loves these 3, 4, 5 right triangles. And look what I just found, a 3, 4, 5 right triangle. So BE is 5x. Now if I'm trying to find the length of DE, I can do so quite easily because if this is a 3, 4, 5, the big dog is a 3, 4, 5, which means that this is just multiplied by 3, obviously. So in this case, AC down here would have to be 9, and this whole chunk would have to be 12. 9, 12, 15 is the same as a 3, 4, 5. That's great. Well, if this is 12, and this side here is 4, this side has to be 8, because 4 plus 8 is 12. If 4x equals 8, that means x equals 2. Plug and chug. 3 times 2 is 6. Boom, done. Oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. Assuming that oil and gas production decreased at a constant rate, meaning it's a linear equation, which of the following linear functions best models the production in millions of barrels T years after 2000? This, of course, means that I should be able to plug in 13 to the correct equation and get 1.9. Now, first of all, if this is a decrease, that means that we need a negative slope. So A and B are out because these, as the years go up, would simply increase. So now I know it's down to one of these two. So again, yes, we can calculate the rate of change. We can set up a slope equation and do all that. But you could also, if you wanted to, plug in 13 to each of these and figure out which one gives you the appropriate change. Since this is a no calculator question, let's go the first way where we're actually going to calculate the slope. So since it's years after 2000, this would be the coordinate 0, 4. This would be the coordinate 13, 1.9. Now we subtract down 4 minus 1.9 is 2.1. 0 minus 13 is negative 13. Now we look at these slopes. They're pretty similar. It's just all they did was they moved this over and they added a 0. So the correct slope is negative 21 over 130, which means C is the winner. And if you want a double verification, you can plug 13 into this and see that you do indeed get 1.9. Okay, we've got another circle triangle hybrid, and as I mentioned before, these are quite difficult. It says in the circle above, point A is in the center, and the length of arc BC, which is here, is 2/5 of the circumference of the circle. What is the value of x? Now, what I would do in this situation is immediately, since we're talking about arc length, go to my arc length formula, which is central angle over 360 times the circumference. And now normally I would put 2 pi r in, but I'm not going to do that here because we're talking in terms of the circumference for the other value, equals the arc length. All right, now we can plug and chug. So they're giving us BC in terms of the circumference, so I'm going to leave it like that. Arc length is 2/5 of the circumference equals the central angle, which is x, over 360 times the circumference. All right, well, why is this great in terms of C and C? And yes, I could have had 2 pi r, it doesn't matter. But nice and simple, divide both sides by C and they go away, which equals x over 360 equals 2 over 5. And now we got a nice proportion. It's not so bad, even without a calculator. Cross, 720 equals 5x. And then we can divide by 5. Now I got a little trick for dividing by 5. You chop off the 0 and then double the remaining piece. So that's 72 times 2, which is 144, and we're done. The equation above models the number of members M of a gym T years after the gym opens. Of the following, which equation models the number of members of the gym Q quarter years after the gym opens? So here's the key part to a question like this, because it's very confusing which way to go. Well, it means that if I plug in 4 for Q, I should get back to this equation as if I were to plug in 1 for T. So first of all, changing of the inside part doesn't make sense to me because that's too many modifications, right? If I'm plugging in 4 here, I'm going to get 1.082 to the 4th power, which wouldn't equal 1, and it's giving me some different percentage increase, so that's out. Same with this guy. First of all, if I plug in 4 here, it would be 16, 1.005 to the 16th power, which is not the same as 1.02 to the 1st power. Now we come down to these two, which are both great options because they both have the 1.02, which is correct. But now is it dividing by 4 or multiplying by 4? Once again, if I plug in 4 here, it would be 16, which is not to the 1st power. But if I plug in 4 here, 4 over 4, which is 1, which brings me back to my original as if I were to plug in 1 for t. That's the answer, and we're done. These problems can be especially difficult for some students. It's a mix of percentages, and then we're really talking about biases. So we're going to break it down carefully, and then we're going to answer before we look at the answers, which is always super helpful. For the finale of a TV show, viewers could use either social media or a text message to vote for their favorite 2 contestants. The contestant receiving more than 50% of the vote won. An estimated 10% of the viewers voted, and 30% of the votes were cast on social media. So 10% of all viewers voted, 30% on social media, and then the remaining 70% must have been through text. So contestant 2 got 70% of votes from social media and 40% of the votes from text. We can then deduce from this, since there's only 2 contestants, that contestant 1 got 30% social media and 60% text. Now we can right away figure out who won and lost because 70%, we can almost treat this as if we got 30 votes and 170 votes and so on. So we can do the calculations even mentally, honestly. 70% of 30 is like 0.7 times 0.3, which is 0.21 or 21%. And here it's 40 times 70, which is 28. So that means that contestant 2 got 49% of the votes and lost. And then contestant 1 got 30 of 30, which is 9, and 60 of 70, which is 42, which adds up to 51. So contestant 1 is actually the winner. Now, normally in a question like this, we'd have some idea of if there's a problem with the surveying method or voting method. I don't really see one yet, so let's just jump into the options. If all viewers had voted, contestant 2 would have won. We have no idea of that because they didn't tell us anything about the remaining 90% of people that didn't vote, so no way. Viewers voting by social media were likely to be younger. They didn't say anything about age. They're trying to prey on the fact that you know that people who use social media more are usually on the younger side. There's no evidence for that. If all viewers who voted had voted by social media instead of by text message, contestant 2 would have won. This just simply means you're changing up the delivery method. Hey, instead of texting, we're going through social media. But why would that impact anything? That doesn't make any sense. Viewers voting by social media were more likely to prefer contestant 2 than viewers voting by text message. So that actually does appear to be true. You notice that 70% of the social media votes went to contestant 2 versus only 40% of the text votes went to contestant 2. So D is the only viable option. And you notice I did end up doing some more calculations than I needed to do, which you want to be a little careful of, but I still like to go in that direction because it helps me frame the problem, especially with all this text and all these numbers. It helps me get my head around everything. So that's it. D is the winner. We can move on. This is a standard deviation problem. Now, these look intimidating and very difficult, but they're actually not that bad because you never need to calculate standard deviation. You only have to understand what it means, and it means the measure of the spread. The greater the data is spread out, the larger the standard deviation. So the 22 students in a health class conducted an experiment in which they each recorded their pulse rates in beats per minute before and after completing a light exercise routine. The dot plots below display the results. So this is before exercise and this is after. Let S1 and R1 be the standard deviation and range, respectively, of the data before exercise, and let S2 and R2 be the standard deviation and range of the data after. Which of the following is true? Now, the easiest thing to calculate first is the range, which is the large value, 88, minus the smallest value, 56, which is 32. And this one is 112. And by the way, you have to have points there to do that. 112 minus 80, which is also 32. So that means the ranges are equal. Boom, boom. So that's very nice. Now the question is, are the standard deviations equal or unequal? As I said, because it measures the spread, yeah, they have the same range, But look how nice and evenly this is all spread out. So this is a larger standard deviation versus this one, it's more tightly packed around 72. So they're definitely not equal. It doesn't even ask which one's bigger, but just knowing that they're definitely not equal is enough to get you to the answer that D is the winner. I find this one pretty difficult because it's sort of a hybrid of function notation, then we got a table, then we're looking at a graph. And so you got to put all those components together correctly in order to get this right. So it says the complete graph of function f and a table of values for function g, so this is g, and these are the f values, are shown above. The maximum value of f is k. What is the value of g of k? So again, first we need to know, what does that mean, maximum value? Well, the maximum value is going to occur at the highest point, which occurs right here. And that maximum value is the y value, the function value is 3. It occurs when x equals 4, but the k value is the actual maximum, so it's 3. Now we want g of k, and if k is 3, we want g of 3. Now we have to figure out, how do I use function notation and the table? Well, I want the value of g when x equals 3, which would be 6. Boom, done. This is an extremely tricky triangle trig problem, but we're going to go through it carefully. I'm going to show you how to tackle it. In triangle RST above, point W not shown lies on RT. So we can say it lies like somewhere here on RT. What is the value of cosine of RSW minus sine WST? First, I'm going to draw a line here. So RSW is this angle and WST is this angle in here. So we'll just note those as follows. So again, this references a particular rule about complements of angles. And while you may not catch this, these two angles that they're mentioning are complements. How do I know that? Because they comprise that right angle. So what did I say before? I said cosine of an angle, it can go either way, but cosine of an angle equals sine of the complement, or vice versa, sine of an angle equals cosine of the complement. But it doesn't matter which way we think about it. Bottom line is, these two guys are complements. So I'm saying this is actually equal to this, whatever it is. It doesn't matter. And that's the thing. W can be anywhere here, but these are always going to be complements. So it ends up, you could even think about it as being x minus x, which is, of course, 0. In which of the following does the shaded region represent the solution set in the xy plane to the system of inequalities above? Now, I think systems of inequalities are quite difficult because I know that it can be confusing as to where to shade, but this is the general protocol. So when I first look at this, I want to graph the actual line. Now, the good thing about this problem is all the lines are the same. Okay, but we're going to want to label appropriately. So y is greater than or equal to x plus 2 is the same as y equals x plus 2, but then shading above that solid line. So first of all, this line here, because it has a positive slope of 1 and a y-intercept of 2, represents the y is greater than or equal to x plus 2. This is obviously represented by this line, but I don't want it in that format. I want to get it into slope-intercept form because that's how we know where to shade. So first, I'm going to subtract by 2x. Then I'm going to divide by 3, and we get y is less than or equal to negative 2/3 x plus 6 divided by 3, which is 2. This makes sense because we do have a negative slope, and we do have the same y-intercept. So again, it's y is less than or equal to negative 2/3 x plus 2. Now the key is, because I've got greater than or equal to and less than or equal to, that tells us where to shade. Greater than or equal to for the green line means we shade above this line, and less than or equal to for the blue line means we shade below the blue one. And of course, this extends beyond where I'm just shading, but we're trying to find the intersection. We're trying to find the solution to the system. So it's that little pocket right there. And as we can see, B is the winner. But the key really is, for the second one, is to get it into that nice slope-intercept form. If y equals 3x squared plus 6x plus 2 is graphed in the xy plane, which of the following characteristics of the graph is displayed as a constant or coefficient in the equation? So again, these can be quite tricky. We've got a few different coefficients. We got a 3, we got a 6, and then we also have a 2 as just a constant. So this isn't in vertex form. This isn't in intercepts form. This is just in standard form. And in standard form, yeah, you can get the vertex or the line of symmetry if you did negative b over 2a, but they're saying if you just look at it, which one can you tell straight away from looking at it in standard form? And that's this guy, because this guy, if I plugged in 0 for x, those would 0 out, and we'd of course get the y-intercept. So the answer is C, and we're done. The system of equations above has no solutions. You gotta know when you read a question like this immediately that it's saying that the slopes are equal to are parallel. Very important. If A and B are constants, what is the value of A over B? Okay, what I would like to do immediately, since I know the values of the slopes have to be the same, I want to put it into slope-intercept form. And it might not be the prettiest looking thing, but the top one I'm going to straight up get rid of the fractions first, multiply everything by 4. So it becomes 3x minus 4 times 1/2 is 2 equals 4 times 12 is 48. Then I got negative 2y equals negative 3x plus 48. Then I'm going to divide by negative 2 and I get y equals 3/2 x minus 24. Great, so that one's in slope-intercept form. Now I got this one. I get negative by equals negative ax plus 9. Then I divide by negative b and I get y equals negative a divided by negative b is just a over b x minus 9 over b because it's a negative b. All right. So if I'm saying that for no solution, these two have to be parallel, they have to have the same slope. Well, now they're in slope-intercept form. It's pretty straightforward. If 3 over 2 is the slope here, and this is a slope of a over b is 3/2, and we're done. In the system of equations above, a is a constant. For which of the following values of a does the system have no solution? Again, what does that mean? If you don't know what that means, you're done, you're hosed. But if you know what it means, you're good to go, and that means that these guys are parallel. They have the same slope. Again, we're going to go for these in slope-intercept form. This one's quite easy. I'm just going to add 3x, and I get y equals 3x plus 6, which means the slope of this guy, and actually both of them, is going to be 3. Then I'm going to do the same with this one, put it into slope-intercept form. 2y equals negative ax plus 4, and then I'm going to divide everything by 2, and I get y equals negative a over 2x plus 4 divided by 2, which is 2. Now, as long as these guys are different, which they are, we don't really have to worry about the y-intercept, but the key is that these two have to be equal. So negative a over 2 has to equal 3, and then we just isolate for a, multiply both sides by negative 2, a equals negative 2 times 3 is negative 6, and we're done. If u plus t equals 5 and u minus t equals 2, what is the value of u minus t times u squared minus t squared? So this is a really difficult, abstract, weird problem, and the thing that I always say on this test is when you see something that's factorable and it's not factored, just factor it. Don't even think about it. So this one is great if you use that protocol because the second expression right there, that second binomial, is a difference of squares. So if we factor it, we get u minus t times u plus t. Now this starts to make a lot more sense because u minus t has a value of 2 and u plus t has a value of 5. Again, if you don't see that, you're kind of stuck. But if you see it, this is amazing because it's just 2 times 2 times 5, 4 times 5, 20, and that's it. The formula above can be used to approximate the length h in inches of an adult male based on the length L in inches of his femur. So this is femur, and this is height. What is the meaning of 1.88 in this context? So first of all, I know that 1.88 is the slope. I know that. And if I can see anything where it talks about the rate of change, we're good. The approximate femur length in inches for a man with a height of 32.01. I know that's not true because if I plug in 32.01 into height, L would have to equal 0. So this is out. The approximate increase in a man's femur length in inches for each increase of 32.01 inches in his height. I can immediately disprove that by plugging in 32.01 and then 64.02 because 32.01 it would be 0, and then to get to 64.02 this would have to be a lot larger to get it up there. It would have to be closer to like 17 or 18. This is out. The approximate increase in a man's femur length in inches for each 1 inch increase in his height. This is sounding a little bit better because, again, this is supposed to be the slope. And if that's the y and that's the x, the slope should be 1.88 in height for every 1 inch in femur length. But this is actually saying the opposite. This is saying for each 1 inch increase in his height, we're going up 1.88 in length. So it's almost there, but it's out. The approximate increase in a man's height in inches for each 1 inch increase in his femur length. That makes sense, right? It's going up by 1.88 for every 1 inch the length of the femur increases. Now we can verify this by doing a little table, as I mentioned before. So if we start with 0 for length, we of course get a height of 32.01. Now we do a 1-inch increase in the length of the femur as they represented there. 1 times 1.88 is 1.88, plus that is 33.89. That indeed represents a 1.88 increase in height, and we are done. In quadrilateral ABCD above, AD is parallel to BC, so we're going to mark that as follows. And it also says CD equals 1/2 of AB, which if that's the case, that means I could represent, instead of using fractions, I can say if this is 2x, CD is just x, and that's a much nicer way than saying x and half x. What is the measure of angle B? So this is really difficult because we're trying to find this whole angle measure, but what you want to recognize immediately in this weird trapezoid, we're really talking about an embedded triangle problem. What I'm going to do is I'm going to drop a line straight down, and the reason why is because this creates a triangle, and that's a lot of times what we're searching for. College Word loves triangles. And if that is the same as this side, which we can tell it clearly is, I can label this as X. Why is that important? 2 reasons. 1, we're creating a right angle here, which means we're making a beautiful right triangle. The other thing is that we've now got one of the legs that is half the length of the hypotenuse. So this should immediately tell you that this is a special right triangle, but not just any special right triangle, a 30, 60, 90. We don't need to know this, but this is the x root 3 side. But all we're trying to do is figure out this entire angle of B. If I know that this is 60, and I know that now I've just created a square, which means that this angle is 90. I know that the entire angle here is 60 plus 90, which is 150, and that's it. Finally, we come to a 2-part question. Again, these are always on the trickier side. So this one says, a peregrine falcon can reach up to speeds of 200 miles per hour while diving to catch prey, making it the fastest animal on the planet when in a dive. What is a peregrine falcon's maximum speed while diving to catch prey in feet per second? So this is a dimensional analysis problem. So I'm going to start by setting it up as 200 miles per 1 hour. And what we're going to do is we're going to do the conversions step by step. So I need feet per second. So first I'm going to get miles to feet. And the way I do that is if I have miles on top, I need miles on the bottom. And we want 1 mile is how many feet? Well, they give us that equivalency. It's 5,280 feet. Cancel the units, and we're in feet. Now I want hours to seconds. So first let's do it step by step. And again, hours has to go on top. And 1 hour is equal to 60 minutes. To get rid of the minutes and go to seconds, we put minutes opposite. 1 minute is equivalent to 60 seconds. The whole reason why this works is because we're all doing equivalent ratios, meaning it's like I'm multiplying by 1 a bunch of times is really what's happening. That's why it's allowed. Now, of course, this is a calculator problem, so we're going to use our calculator as follows. On the top, we've got 200 times 5,280 divided by 60 times 60, which is 3,600. And the answer rounded to the nearest whole number is 293. Finally, for 38, if a peregrine falcon dove at its maximum speed for a half mile to catch prey, how many seconds would the dive take? What I'm going to do is I'm going to use the formula distance equals rate times time. If you don't go back to that baseline formula, this can be really tricky and a little bit overwhelming. So I like to always go back to that framework. Now, we're saying the distance is a half mile. The rate, since we're talking about miles, I'm going to go back to the 200 miles per hour rate. And now we're solving for time. The thing you got to remember is this is going to solve in hours. Because it's miles per hour. It's all about the rate. So once we get this value, we have to convert it to seconds, which is no problem. So I'm going to divide both sides by 200. And this is basically the same thing as 1/2 times the reciprocal of 200, which is 1 over 200, which equals 1 over 400. But that's in hours. Now I want to convert this to seconds. So if I were to convert hours to minutes, of course, I'd multiply it by 60. And then if I'd want to convert it to seconds, I'd multiply it again times 60. And we'll put it over 1 over 1. This now becomes 3,600 over 400. Cancel, cancel. 36 over 4, which gives me an answer of 9 seconds. In my estimation, this is as hard as it gets. And if you can break these problems down carefully as I did and crack them and solve them, you are in that 750 to 800 range. Just remember, this is a finite universe of math. There is a system to each and every problem. And if you really watch with care and intent, take notes, do your homework, do your due diligence, you can beat the test. I hope you enjoyed this video. And if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you so much for joining, and I wish you all the best of luck in your SAT journey. Take it easy.